Hi, this is a presentation of some of the advanced settings in RIGRP and also a little bit about how to troubleshoot RIGRP. And it's part of my CCNA3 class. One important thing we need to be aware of when we are using RIGRP is that it performs auto summary by default. And it will perform auto summary to the class full boundary, which means that if I have a class B, for instance 172.16.2.0/24, which is in the classful sense a class B address, it will perform an auto summary with a /16 subnet mask. So when router 2 in this case here performs or sends out updates to the rest of the network here, it will send out that I have a network called 172.16.0.0/16 because it will perform a auto summary by default. And the same will happen down on router 1, where we also have a 172.16.1.0/24, but since RIGRP will see this and perform the auto summary, it will send updates about 172.16.0.0/16, and we can see we have a problem then, because we will have the same network in being present twice in our domain, and that will not work. So if we have networks like this which are not continuous, it's called discontinuous networks, then we will have to turn off the auto summary. So we can here are if you don't remember the class A, B, and C IP addresses, we will see that from if it starts with 128 and up to 191, it's actually a class B network, and in this case here 172 is a class B. So the default mask will be a /16, and it will summarize to that. If it's a class A, it goes from 1 and up to 127, and then the default mask is /8. And the class C networks are networks starting with 192 and up to 223, and here our standard mask is /24. So if I want to turn that off, well, it's quite simple. Well, I just go into router RIGRP and then put in the correct autonomous system number, and then I say no auto summary. So if you think that you have done everything correct and you have actually used subnetting, well, then you need to make sure that auto summary is turned off if it doesn't work. So you can see that if you use the show IP protocols, then you will see that you're using RIGRP, and you can also see that automatic summarization is enabled. You can also see that in your routing tables or in your topology table here, where you can see that it has a default, it has automatically set it to a /16 address. And also if you do a show IP route, you will also see that it has a route to 172.16.00/16, and it's variably subnetted into these 3 different subnets, for instance. But what it will advertise to the rest of the network is the summarized route. Because we want summarization. Summarization is good because that makes our routing table smaller. But what we can experience also is actually a routing loop. And RIGRP has already taken care of that for us, but just to show you the extent of what could happen if it hadn't taken this into consideration. If we, for instance, here has router 1 and router 2. Router 2 sends an update to router 1 that I have a summarized network called 172.16.0.0/16. And router 1 has a default route. So whatever doesn't fit into some of the entries in our routing table will be sent to router 1. And then router 1 now has an IP address to a network called 72.16.4.10. and it will look into its routing table and see, okay, router 2 knows about the network 72.16.00/16. So it will be sent to router 2. Router 2 will then look into its routing table, and in this specific case, it does not know of any network to 172.16.40/24. It knows of 1, 2, and 3. But it has a default route to 4 times 0, so it will send it back to R1. And R1 will receive this one, and it will look into its routing table and see that 172.16.00 is on router 2, so it will be sent in a loop. But the ones who created RIGRP has thought about this, and what actually will happen is that we have a null interface or a bit bucket. In this case, that whatever comes, we will still send out the summarized route, but it will also, if something comes to 172.16.4.10, it will send it to the bit bucket because it doesn't know of this network. So, and that is, the bit bucket is the null interface. You will see that within the routing table here, that whatever else is to 172.16.00/16 will be sent to the null interface. So in this case, we will then prevent the routing loop, and this is implemented in RIGRP. If we want to create a manual summary route, we can of course also do that in RIGRP, and it's the same thing as we did in OSPF. When we did this, we will of course need to find out first how can we summarize, and by doing everything in binary and counting the corresponding bits. And in this case here we have 22 matching bits, so we can have a /22 subnet mask on these 3 addresses. And if you want to do so, you can see here you go to the interface where you want to send out the summary route, and then you go in and use the IP summary address RIGRP, and then the network, the summarized network, and the new subnet mask, and then it's sent out to our serial 00 interface here. And we can see that by using a show IP route. We have now a /22 subnet mask. Yeah, we can of course also do that in IP version 6. Normally it's not something that we will deal with in IP version 6, but of course if we can do it. And the default mask in IP version 6 is /64, but of course if we change that, here we have a /48 subnet mask, for instance, which means that we have a summary route. We do it the exact same way, but with an IP version 6 summary address, RIGRP, and so on. If I have a default route in my network, if I have at one point where I have my internet connection, for instance, and I want to that all of my other routers in the domain use the same internet connection, well then I can redistribute my static routes, and I do that with the redistribute static. Then this static route will be sent through the RIGRP updates to the neighboring routers, so they also can use that. So I don't have to put in the static route on all the other routers. And we can see that if we have an external route or a static route by the EX in the routing table. This means that this is a route that has been redistributed through RIGRP. And we can see also that the administrative distance here is 170 for an external RIGRP route. And the same thing we can do in IP version 6. If I have an IP version 6 default route, it's just 2 dashes, and that is yeah, a lot of zeros, which again is the default route. And I can do the redistribute static here as well in IP version 6. By default, EIGRP will only use 50% of an interface bandwidth for their own updates, which is good. Of course, we should not use all our bandwidth for the routing protocol itself. So by default, the percentage is set to 50. This is a number that can be changed. If I wanted to set it up or I want to set it down, I can do that with the IP bandwidth percent EIGRP and then the percentage that I want to put in. I think today bandwidth is not really an issue, and the updates sent by EIGRP are quite small. In earlier days, when we have modem connections and ISDN connections, this was actually quite important. Yeah, and the same thing applies for IP version 6. We can also set the hold down timers and the hello interval to something else than the default values. As you can see here, if I have a slow link, the default value is 60 seconds. If I have a faster link, the default is 5 seconds. And if I somehow want to change that, I can do that with the IP hello interval and IP hold time if I want to change those. We've seen also that that EIGRP will load balance between equal cost paths, and we can set a maximum value for that. I think the default is set to 4, but it can be set up to 32 equal cost routes can be kept in the routing table. So if I want to change that, I can use the maximum path and then a value for that. Yeah, and the same thing we can do in IP version 6. It can also be load balanced. Another thing we can do in many of our routing protocols is to set up authentication. If I want to authenticate the updates coming from my neighbor and I want to make sure that this is a router that I know of, we can set up, for instance, with MD5 authentication. And to do so, we need to create a password and a username. So we use the key, first we create the key chain, and then afterwards we say that we would like to use this key chain on our router. And it's maybe a good idea, especially if you have more open networks and you want to make sure that there isn't somebody pretending to be a part of your EIGRP updates, but it's a real EIGRP update. Yeah, and then you can see that with the when you create the key chain. And this is an example of how to set it up. Yep. And it can also be done for when you're using IP version 6. And you can verify it afterwards. And that's it. And the problem shooting or the troubleshooting, yeah. Well, we have tried and set things up in the lab, and we will always have some issues. And I think you know now that there are these different show commands that are useful. Show IP protocols to see which routing protocol that you're using and which networks, because what you normally do is that you forget some of the networks that you want to use for the routing protocol. The show IP route will show you if you actually get any information from your neighbors. And the show IP EIGRP neighbors will show you if you actually can see your neighbors, and the same thing applies in IP version 6. And show interfaces, for instance, also is something that we use, and show run to see how everything is set up. And I think this is what you need to know. The basic issue about EIGRP is the networks. You need to make sure that you know which networks that you are using and that it performs auto summary. And that's it. Thank you.